So, let's see. The square root of -1 has no solutions. But this is where the complex numbers come. Because this is supposedly equal to a number called I. So that's cool. You might think, oh, just move on. Except it's hard to move on when we have crazy equations like I to the I. Like, we have to solve this. So that's why in this video, I'm going to be solving the equation I to the power of I. So, Euler's identity says that e to the power of I times pi is equal to -1. I'll explain Euler's identity in another video. So we can take the square root of both sides. So this part gives us I, and using a rule of what I know about exponents, n, the square root of n, equals n to the 1 over 2. So, because of this, we can write this square root as putting this to the power of 1 over 2. E to the I pi, this term raised to the 1 over 2. And another rule of exponents I know is that a raised to the b, the value of that raised to the c, the value of that raised to the c is equal to a to the b times c. So we can use that for this 1 over 2 times I pi. Well, just put I pi into the numerator, giving us e to the I pi over 2. And then we have the other side, which is still equal to I. So, since this is equal to I, we can substitute it in for I, giving us, let's clean this up a little bit, e to the I pi over 2 raised to the I, that's equal to I to the I. And right here, I to the I is what we're trying to solve. But using the same rule of exponents I used earlier, we can multiply this I by this fraction right here, giving us that e to the I squared pi over 2 equals I to the I. We're getting really close. So, I squared, we saw that the square root of -1 is I. So that means that I squared is -1. So we can represent this as I to the I. Our answer is that I to the I equals e to the negative pi over 2. And that is our answer. It's surprising because this is a real number instead of these imaginary numbers we have here, I. So it's crazy how putting an imaginary number to an imaginary power gives us a real value. That is insane. But there's your explanation on what I to the power of I is.